Quick reality check. Roughly 6 in 10 students pass GCSE maths. For research students, the pass rate drops to something like 1 in 6. And most of these resets are in the foundation tier. But before we go any further, if you've taken foundation and passed, congratulations, genuinely. That's a fantastic achievement. This video isn't a dig at students or teachers, it's a critique of the qualification itself and how it could serve learners better. I've taught foundation mathematics for years and I don't think it's doing what it's meant to do. It's too broad. It pushes shallow coverage over real understanding and it doesn't emphasise helping students to use maths in everyday life. In this video, I'll explain where foundation maths GCSE has gone wrong and what changes would make it a qualification that actually makes sense. As someone who enjoys mathematics, values learning for its own sake, and academic rigour, I'd love the whole country to revel in maths and take their understanding to a higher level. However, as a tutor who's worked with thousands of students, I also recognise the gap between ideals and reality. Bringing the paper more in line with real life should be the goal of awarding bodies like Edexcel and the Department of Education. So, what even is foundation maths? It's the lower tier of GCSE maths. It awards grades 1 to 5, and a grade 4 counts as a pass. Everyone at this tier sits 3 papers, 1 non-calculator and 2 calculator papers. Foundation is the route for students who need a solid, practical base. In theory, that all sounds sensible. The problem is how it plays out in practice. So what's not working? Problem 1. Too much, too thin. We skim topic after topic, just enough to survive an exam question. And it's gone, a week later. Students don't get time to master the big ideas. Problem 2. Niche, non-practical topics. We burn lessons on things that don't pay off for most foundation learners. For instance, memorising exact trig values, like these. These are useful if you take mathematics to a higher level, and potentially interesting on the surface. But what's the point for a foundation student? Take quadratics for instance. Factorising shows up in foundation too. It's another concept that is touched upon and that students need to know about at a foundation level. Of course, these can be used to solve real-world problems. But do foundation students really need to know this? Here are some questions taken from the Edexcel foundation papers that seem a step too demanding for those candidates. They're enjoyable for those who love maths, but this isn't who this tier is for. Now, I'm not going to go through every step of every one of these questions. That's not what this video is about. If you want to see me work for a full foundation paper, you can click up here. But roughly speaking, in this question, you would have to use the straight line graph formula y equals mx plus c and substitute the first set of coordinates to find c, which is the y-intercept, and take the second set of coordinates into this new equation and find the x value of the second coordinate. Now, I don't know about you, but I think that's too much for a foundation student. They don't need to know a concept like this to that level. If you're a parent watching, have a go at some of these questions, because that will give you a good idea of the sort of things that a foundation student has to go through. Problem 3. Weak links to real life. With pass rates as they are, foundation should be laser focused on the numeracy people actually use, like money, data, simple models, and confident calculation. So, with those problems in mind, what would I change if I had full control? In a nutshell, I would implement a shift from covering as much as possible to mastering and prioritising what matters, whilst making it useful for real life. The current maths foundation does include many of the following areas, but I would increase the focus on certain areas and reduce the emphasis on others that are not as important. Number 1, make financial maths the spine. Students should leave school able to read a payslip, plan a budget, compare savings, and not get confused by percentages. So we'd work on concepts that are, some of them that are already in the foundation syllabus, but I'd expand it. So you've got simple and compound interest, depreciation, decay, profit and loss, unit pricing, tax NI, so national insurance, inflation, ratios and percentages and multipliers in context. And then what you do is take that knowledge and you build it into case studies. So we look at energy bills, phone plans, travel cards, subscriptions. They do a bit of this already, but I try to make it even more practical and probably use more realia. So actually showing some of these documents and in the formats that they'll be in. You'd also take this maths and use them in spreadsheets. So with formulas, autofills, absolute relative references, simple charts. This is real life. I've done this a few times with students and it's really helped them understand concepts better. Number 2, teach data and statistics people can use. Although AI can crunch numbers and probably will do the vast majority of analysis in the future, you will still need to be able to spot nonsense and understand how to interpret the data. So what you teach them is to read tables, charts and dashboards, understand averages, mean, median, mode, and spread, range and interquartile range, talk about risk, rates and sampling bias, identify misleading axes, understand correlation is not equal to causation. And you'd finish with a mini data investigation. So you grab a small data set, clean it, graph it, write a short what it means paragraph. Number 3, I'd keep algebra as a toolkit and not a maze. So I'd concentrate on rearranging basic formulas and building small models that apply to real life. Quadratics? Well, I'd keep simple factorizing and make them aware that they exist, but I wouldn't go into any real depth there. Essentially, it's not particularly useful for them. And finally, number 4, build numeracy confidence. So mentor in rough methods, estimates, fractions, decimals, percentage, fluency, those sort of things. Units, that make sense. These skills matter as they basically fall into the realm of common sense. We do not want British people walking around not knowing their basics. These basics are also crucially important for maintaining accuracy in basic jobs. Those key skills in those 4 operations are what really matter. Also, calculator literacy. So entering expressions cleanly, interpreting outputs, rounding appropriately, checking if an answer is sensible, and also just being able to type into the calculator without it generating the wrong results. So things in the right order. So that's how I would change the curriculum. And this is how I'd assess it. So I'd have paper 1, which would be 75 minutes. So we'll have mixed short questions across data interpretation and presentation, number and algebra. It would start by initially focusing on pure numeracy and concepts everyone should know. Essentially, those primary school maths concepts. The time limit should be slightly stricter to ensure students learn to work with speed and accuracy. My second paper would be based on real-world contexts, and it'll be 90 minutes long. It should allow for the use of a calculator, as this would better reflect the real world. So this would include things like energy bills and smart meter graphs, or travel cards and break-even points. Marks would be awarded for method, clarity and sensible assumptions, not just the final number. Although, to be honest, that's something that the ordinary paper has. A bit more time would be provided so that students have space to interpret the concepts. Next, I would add an applied project, which would make up around 20 to 25% of the final grade. Something like a spreadsheet-based mini project, such as planning a budget for an event, comparing savings and the cost of products over time, or analysing a small data set. Students would submit the sheet and a 1-page write-up. Teachers would verify authenticity, and exam boards would moderate examples. This captures planning and judgment, something that a time paper cannot do. Many experts and politicians would probably argue that we would be watering down the maths, but they are wrong. We're refocusing. The fact is that if 4 out of 10 students are failing, and the pass mark ranges between 40 to 60%, which would indicate that the material is not being mastered by the majority of students in the first place. It's like handing out driving licenses after the theory test. They know the highway code, but stall at the first junction. So, foundation math shouldn't be about learning a huge number of concepts, but it should emphasize key and practical concepts that help students learn to work accurately, think clearly, and apply their knowledge to the real world. That strong base also keeps doors open if students want to deepen their understanding of maths later. The solution may be to introduce the intermediate paper back, so that more students at the high end of foundation and the lower end of higher have a good balance between material that stretches their ability and then reduce the difficulty of the foundation paper whilst taking their understanding of core concepts and practical applications to a higher level. So what would you do? If you teach or are studying Foundation Maths GCSE, let us know what you would add, drop or double down on. Pop your thoughts in the comments and we'll see you down there. To watch me go through a full foundation paper from start to finish to see exactly what these students have to go through, click on this box here and don't forget to like and subscribe.